In critical systems, failure is not an option. When fire breaks out, seconds decide everything. Heat spreads fast, smoke spreads faster. If a door fails, escape disappears. These are not ordinary doors. They are designed to stand between life and disaster. In these systems, failure is not an option. So how is this level of safety achieved? The answer begins here. Inside a factory where every detail is controlled, everything starts with material selection. Standard steel is not enough for this job. Special alloys are used to resist extreme heat and pressure. Under fire, metal behaves differently. Design must account for this change. A single layer will always fail. Real protection is built in layers. The most important layer is hidden inside. Some materials expand when exposed to heat. They seal gaps before smoke can pass. In fires, smoke is often deadlier than flames. That is why smoke sealing is critical. There is no room for leakage. Fire also creates mechanical stress. The structure must hold under pressure. Designs are not trusted until they are proven. Once verified, manufacturing begins. Raw steel enters the production line. This is where theory becomes reality. Laser systems cut steel with millimeter precision. Every component is measured. Every tolerance is verified. Hydraulic presses shape the panels under extreme force.
The alignment on layer 3 is off by 2 millimeters.
The door body begins to take form.
The laser calibration needs adjustment before the next sequence.
Multiple layers are assembled together. Redundancy is intentional. A fire-resistant core is injected into the structure. Layers are permanently bonded. There is no separation allowed. Frames are manufactured separately. They must be just as strong as the door itself. Frames are reinforced at stress points. Door and frame alignment is critical. Even a small gap can mean failure. Sealing channels are machined with precision. Intumescent seals are installed. They activate only when exposed to heat. The locking mechanism is assembled. This is the heart of the system. Multi-point locking ensures uniform pressure distribution. Mechanical movement is tested repeatedly. The door must operate flawlessly. Protective surface coatings are applied. They reflect heat and slow degradation. coatings are thermally cured for durability. Final assembly brings all components together. Sensors are integrated into the system. Each sensor is carefully calibrated. Visual inspections detect even microscopic defects. The system is moved to the testing chamber. Once inside, the chamber is sealed. There is no second chance. The test begins. The testing phase begins. There is no reset. Once the chamber is sealed, the system stands alone. Every lock engages. Every variable is now controlled. Sensors activate across the entire structure. From this moment forward, failure is not an option. Temperature begins to rise inside the chamber. Heat changes material behavior at a microscopic level. Thermal sensors track every degree in real time. The internal core starts carrying thermal load. Expansion is calculated long before this moment. System remains perfectly aligned. Heat crosses the first critical threshold. The structure holds its shape under stress. Direct flame contact begins. This is where most systems fail. Protective coatings, slow surface degradation. Temperature spikes sharply within seconds. Thermal stress spreads through the structure. The frame absorbs increasing pressure. If the lock fails, everything fails. This system was built for this moment. Failure is not an option. Smoke pressure begins to build rapidly. Smoke searches for the smallest opening. Heat-activated seals expand automatically. Gaps are closed in real time. Leak detection systems begin scanning. No leakage is detected. Pressure continues to increase. The system remains sealed. The system approaches its mechanical limits. Structural stress reaches peak levels. Locking mechanisms take maximum load. Multi-point locks distribute force evenly. Any failure now would be irreversible. This is the moment of truth. The system holds. Failure is not an option. Time becomes the final test. Endurance separates safety from disaster. Most systems fail at this stage. This one does not. The test ends. The chamber opens. The system stands intact. Failure was never an option.